Alright, so I'm going to go ahead and take a look at this problem here. And I'm going to solve it using variables first, just to begin with. So the first thing I need to do is I need to solve for the coefficient of friction that affects this system. And the way we do that is that we know that there's an applied force F. Now they tell us it's 12 newtons in order for the top block to slide. And we've got M2 down here, and there's no friction there. But I'm going to figure out what the static coefficient of friction here is between the two blocks. So I want to begin by just drawing a free body diagram here of this system. So I've got the normal on one, I've got the weight on one, I've got this applied force F, and I have a friction force going backwards. Now this is block 1. For block 2, I'm going to actually have the normal force on 2. I'm going to actually have a normal force, and by the way, let me be clear, the normal force on 1 is due to block 2 pushing up on it. So I'm going to have a normal on 2 because 1 pushes down on it. I'm going to have the weight of block 2, and I'm going to have a friction force pulling block 2 forward. So these two forces are third law pairs, as are these two forces here. And basically all I'm going to do is I'm going to go ahead and set up some equations to describe this system. So for block 2 I have that the friction makes block 2 accelerate, and for block 1 I have the applied force having a tug of war with the friction, and the effect is that block 1 accelerates. So keeping this in mind, I know that the friction force is going to be mu times n. And in this case, I know that the normal force is m1g in the y direction. So I'm going to use that fact and the fact that friction is mu times n to get the force of friction and therefore solve for mu. So I'm going to have mu times m1g equals m2 times a. And I also have F minus mu m1g equals m1a. And so what I need to do is I'm going to go ahead and I can actually rearrange this equation and put these two equations together and solve for the coefficient of friction. So the way I'll do that is I'm going to actually go ahead and isolate a from each side, and I'll have mu m1g over m2 equals F minus mu m1g over m1, and then I can go ahead and isolate my mu by multiplying through. So I'm going to end up getting mu times m1 squared g equals m2f minus mu m1 m2g. And I'll keep going here. All of this is just to get mu, so I'm going to end up getting mu m1g times m1 plus m2 equals m2f. And when I finally solve, I'm going to get that my coefficient of friction is going to end up being m2 times f over m1 times m1 plus m2 times g. And then I can actually go ahead and plug in my numbers to get mu s. And once I get this mu s, I can use it to solve part A and B in this system here. So I am going to make a suggestion. I want you guys to actually attempt to do A and B as a problem. I'm going to give you guys some hints to set it up, but I really want to see if you can hammer this one out on your own. So let me add a little note page here, and I'll actually go ahead and get you set up with the second part. And once again, let me just, this guy here, there we go, we got our little mu s. We can copy it and paste it here. We can go ahead and solve for it eventually. And we'll get a number there, but let me just go back and see what this page is about. So now it says find the magnitude of A, the maximum horizontal force that can be applied to lower blocks so that the blocks will move together, and the resulting acceleration of the blocks. So here's the idea. Now we have a new situation of we've got block 2 and block 1. And now we're applying the force, a new force to block 2. I want to be clear here. This force and this one, they're not the same. They're going to have different values. So I'm actually going to give this force a different name. I'm going to call it force nu. Okay, and so when I set up my free body diagram, I'm going to end up getting, for block 1's free body diagram, I'm going to end up getting, I've got the normal on 1, I've got the weight of 1, and what I'm going to end up having is the friction from on 1 due to 2 pushing it forward. And then for block 2, I guess I could just call it the static friction, just like I did in the previous problem. And then what I'm going to have for block 2 is I'm going to end up getting a normal on 2. I've got the weight of 2. I've also got the normal on 2 due to 1, so I should be kind of clear in my labeling here. I've got my new applied force, and I have the friction force on 2 moving backwards. So this is a slightly different free body diagram and setup. So what I want to have you do is I'm going to set up the equations for you in the x and y. So for block 1, it's going to be F static makes block 1 accelerate, and I'm going to end up getting that the normal force is m1 times g. I'm also going to still have the fact that the static friction is mu times m1 g, where mu is what I got here in the previous part. And then for block 2, I'm going to have that the normal force fights the friction to make block 2 move. And that's pretty much the equations we got to set up. I am going to leave it to you to go ahead and solve those equations and get the answer. So if you want additional help on this, what I want you to do is I want you to solve this, and I want you to come in, and I want you to check with me. So this is a bit of a mean trick, but it's not really a trick. It's that I really want you to you know, kind of get in the habit of getting a little bit of extra help outside of class if you need it. Just the idea that 5 or 10 minutes really can straighten things out. So I do hope you'll try this problem and come and see me. Thanks.